he's also a member of the St. Joseph's Nature Sanctuary. So he'll give his presentation. Peter, I don't know if you want to give more of an introduction on your history, but thank you.
Well, here's a puzzle for you, not Albanian snails. I was born in Nigeria. And my father was a doctor out there, and he graduated from the medical school in 1939, which was a tumultuous year in world history, as you know. And he was sent instead of to the whatever front there was at that time. He was sent to look after a leprosy hospital, and he stayed there for 20 years until Nigeria became an independent country, and that's where I was born. And I'm wearing a Nigerian shirt because I don't know if you're aware that the Rotary International, I'm a member of the Rotary Club, has had for quite a while, since the 1980s, has had an effort to eradicate polio from the world. And one of my colleagues from Quebec brought this shirt back and had it on auction, and I bought it. So here we go. I'm wearing the Nigerian shirt. I've been here. I had the good fortune to marry Gina Ann Pollard, who's in the back there, and eventually managed to bring me back to Maine, which is her home, in Winslow, where we've lived for 45 years now. And so I studied some geology in England, of course, which is where I went to school and first learned about geology in high school, and got fascinated in it there. And of course, since coming here, I have to learn about the geology of Maine so I could teach you. And the geology of Maine is very different from the geology of England, Scotland, and Wales, as we won't deal in all of the details, but some of them, which I've written up here in colours. The geology of Maine includes three portions. One is the bedrock geology, which is big yellow area, which is from Precambrian times until about the Devonian. Then there's a big missing period, which is the blue. There ain't nothing here. And then there's the post-glacial stuff on top. And we'll get into how these work. So these are the two maps of the geology of Maine. You recognize the shape of Maine in both maps, but the maps are very different colors. This pays homage to my artist wife here. This is a kind of a mock-up somebody did in fabric, and it shows the Precambrian, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and very little Mesozoic here, down here in the corner. These are all the old rocks of Maine. This is what we call ledge, or the bedrock of Maine. Then there's this map here, which is a simplified version of what lies on top. So it's what you grow your gardens in. All the superficial features of Maine are basically from the last 15,000 years. So there's old and very new. Very new, meaning not as new as it should. Much later. And then here are two other maps showing the bedrock geology Precambrian, which is over 600 million years old, are these red pieces. They're quite a bit along here, and we'll get into that a little bit. And then there's a funny little patch back here. And then Cambrian, Ordovician, Silurian, Devonian, Carboniferous. I don't know if you've heard any of those names before, but they're pretty old. They're called the Paleozoic. That's the early fossils. You've probably heard of trilobites, have you?
Yes.
Very good. I like that nodding. So, trilobites lived in the Cambrian, Ordovician, Silurian, and haven't been around since then. And the Mesozoic, Cretaceous, Jurassic. Do you see little tiny patches here? Almost nothing. But one of the things that I want to particularly point out is that this is all old, and it doesn't necessarily reflect the topography. So we have a mountainous northwest, and it's not exactly a coastal plain, but a lower lying area to the southeast. So the topography doesn't reflect the geology at the particular point I'm trying to make. So the big picture is that we lie on the edge of the Canadian Shield. This red area here is the Canadian Shield, which is the oldest part of North America. And I don't know very much about it, and in fact not very much is known about it because it's so old that there are no fossils, and besides it's mostly metamorphosed. Then there's the blue kind of edges on it, particularly our edge over here, is the Appalachians, is this line here, and Maine is, oops, I mustn't put my finger anywhere. And then almost all of the rest of North America is fairly new, much younger geology. And here again, in a kind of simplified version of that map, there's the North American craton, the continental crust that's remained relatively stable for past 600 million years. 600 million is basically the beginning of the Cambrian, the end of the Precambrian period. And that underlies a lot of southern US, not all of it, but goes down part of Texas. Anyway, it underlies it. There are younger rocks on top. In our little portion, there's this kind of purple color here is added continent, and we'll get to that. Just think, addition. So, long before I ever knew about it, there was an ocean to our east. It was called Iapetus, and it was actually closing at the time. So you know that the Atlantic is now opening right now, and Iapetus Ocean was closing, and bits of Scotland and Northern Ireland are now attached to England and Wales, and part of New England was added to the Canadian craton. Kind of weird, eh? This is where it was added. Now you see Waterville, you see Bangor, Orono. This is the Norumbega Fault, which is the place where that land was added. So if you can imagine this little piece here bumped up against the continent of North America as it then was. Ouch. So there are all kinds of Precambrian and Cambrian rocks there, and it's really quite complex, as you can see. Lots of different rocks, and I won't begin to explain them all. These pink areas labeled Pluton. I don't know if you can read that, but those are granite bodies, mostly granite, which are intruded into to metamorphosed sedimentary rocks. You all know about the sedimentary metamorphic igneous rocks? Please nod if you do. No, you don't. Okay. Sedimentary rocks are like sand and clay and boulders and gravel. And they are deposited by rivers or by wind or mostly in the ocean, mostly marine sediments. And in Maine, most of the sedimentary rocks we have are actually deposited in an ocean, like Iapetus. There were sediments being deposited in here, eroded from the land masses, okay? And then they were crushed together like this. And so a metamorphic rock is either a rock that's pushed together or usually pushed together with the addition of quite a lot of heat. So the mineralogy, the minerals in those rocks are changed, either their shape or actually their composition has changed. And sometimes the heat is so much that they actually get molten, and then they get pushed up, for instance, into a volcano, or they get to crystallize and solidify inside the rock, in which case they're what's called here a Pluton.
Is that always granite then?
And yeah, granite is one of them. It's one of the rocks. It's the most common. Okay, I bring this in here just again to emphasize that this is the real old rocks. This is Maine. You can't really see the outline of it with the addition of some rocks. And this is the Appalachian lineup here. And these are sedimentary basins to the west of the Appalachians. I say sedimentary basins a long while ago. So it's all rock now.
I think the Great Lakes, they look like them.
Yeah, the Great Lakes, yes, were part of those sedimentary basins. And we'll get to the Great Lakes briefly a bit later on. So this is a view from Lewiston in the Middle Ordovician. Seriously, it was something like that. And if you can imagine, there's some. So here's the Iapetus Ocean here, and more of it over there. How many of you have heard of continental drift? Most of you. Okay. Well, we'll be seeing a bit more about how continental drift has affected us here in Maine. But basically, it's something like this. The oceanic lithosphere comes down here, and it's heated when it gets down here, and it may come up as a volcanic arc. And in this case, it formed the Casco Bay group and a Falmouth Brunswick group, and I won't get into the details of that, but you can see the kind of complexities of the geology of the coastal area. So here's the metamorphic zones. So the redder ones are the highly metamorphosed. The mineralogy has been changed most radically until it's almost molten. And up in the county and up in northern Maine, it was a very low grade metamorphism, weakly metamorphosed, hardly changed at all. So they're mostly shales. Do you know what shales are? Anybody not know what shales are?
Not know?
Yeah, not know. Shales are basically silts and muds, and we have a lot of shales, actually metamorphosed shales here. Now all of this, this is a metamorphic map, but a bit later on I'll show you a piece of rock that shows that the pushing of the continents together was happening as the shales were still soft and wet. This is going on. So here again, you see that the Norumbega fault with this all of basically coastal Maine was brought across the Iapetus Ocean and pushed against Maine. From away. There you go. I like that. And then, all right. Here's another. So you can see all of these lines here, more or less vertical lines, and not necessarily. Those are faults where one piece of the crust is moved against another like that. Or sometimes there's an almost horizontal fault where it's called a slip fault, which moves a whole bunch of rocks above. There are places like that. I've seen them in the Alps, but I haven't. You can't very easily see them here. And when the continental drift comes along, there's often a trench above the on the edge of the continent, and you get a volcanic arc and a batholith. So batholith is a word that is used for the I don't have it here. For these igneous intrusions, all the grey, almost all of the grey masses on this map here are intrusive igneous rocks, mostly granite.
Peter, we have a question.
Yes.
Would those faults have caused the activity that we've had recently with our houses shaking?
Have you noticed? I haven't.
Yes.
Really?
We
Yes.
have.
Ah, okay. The answer is that if there is activity, it would generally move along a fault. Yes, and so maybe, and I don't know. I haven't heard about
China,
it.
and I heard Winslow, and I heard Augusta, as far away as Augusta, somebody else.
Really? Okay. Yes.
It was on Facebook.
Oh, it must be true.
No, I'm just saying, people said the house
That
was
was
shaking.
actually notable, we heard the noise coming,
Yeah.
we felt the house go back a way, and that's the campus in Winslow.
Yes. So yes, the answer is that if there's that's called an active fault. Most of these are more or less passive faults, but yes.
Peter, can you talk about where is Katahdin in this? Katahdin,
Katahdin is this gray area.
is this intrusive igneous rock?
Yes, it is.
Is that's not typical of all mountains, right? Some mountains are just.
No, as a matter of fact,
Right.
obviously that's that's a granite mass that sticks right up there. But here's a granite mass that sticks right down. It's called Sebago Lake. So that they've got eroded, and we'll be getting to that in a minute. So we've done that. Okay, now, how many of you had heard of Pangaea? Hey, I'm impressed. Been to good high schools.
Let's go to Gondwana to get some people.
So, this is kind of a mock-up of what the supercontinent was, called Pangaea, where almost all of the land masses on Earth were congealed into one supercontinent. And you can see where North America is. It's bumped up right up against South America, and South America against Africa, and India a long way from Asia.
Yeah.
So, and Australia is not an island, it's on the whole. And so here's another way of looking at Pangaea. There were a bunch of little island arcs here, and animals, including dinosaurs, of course, that roamed across from one continent, like South America, to another continent, like Africa, because they were one and the same. And if you like that, you can wear it on your teeth.
Have those for sale here?
Now, the Great Divide. Shut off thoughts of big bedrock, Maine. And you see
Oh, yeah.
black rocks here, which is basalt. This is called a basaltous dike, and it fills a crack in this granite, this pinky gray granite. And it's considered one of the first signs of the breaking of Pangaea to form the Atlantic. It's not necessarily the only sign, but it's one of the very few signs we have in Maine that this was about to happen. And then there isn't a geological record in Maine from about 140,000 years ago, Cretaceous. We have a little tiny bit of that, until about 14,000 years ago, the end of the Pleistocene and the beginning of the Holocene. The Pleistocene, by the way, is the ice ages, the period of ice ages, and there were quite a number of them. But it's only the end of the last one that comes as a part of the history of Maine. Do you remember that slide I had at the beginning of a big yellow space and then a big blue space? This is the blue space.
Okay.
This is why. You recognize where we are? Yeah. This is the area that was covered by ice in the last. This is about 18,000 years ago, 18 to 22,000 years ago, something like that. And you can see it's pretty well all of Canada, quite a bit of the U.S. and particularly all of Maine and all of the Gulf of Maine, right up to the edge of the continental shelf right here. Ain't that something?
Yeah. So it's an exposed continental shelf. That was the part that's sea now, but it was land then.
Well, you probably don't know this, but the continental shelf has a geology similar to the continents. It is a different kind of rock. from the ocean crust. And so off the continental shelf, it's much deeper. There's a steeper drop off here than anywhere in the Gulf of Maine. And one of the most extraordinary things that I only learned about a little while ago, and that is all that ice up there, and you kind of see the outlines of continents as if one could actually see them. Where did all that ice come from? The oceans, I imagine, as wise lady said. And it did, in fact. It's just, you know, the water cycle. Water cycle is that that warm water evaporates. It comes in as clouds and it rains, and then of course it runs down to the ocean again. But if it freezes, it's taking it out of the oceans. And so the ocean, the surface of the ocean dropped 400 feet.
400 feet, yeah.
Wow. Because of that. Ain't that something? Of course, there's more ice on Antarctica. But anyway, the thickness of ice over Maine was about a mile. And why am I showing that picture?
The clouds are about a mile high.
Exactly.
Oh,
The bottom of these clouds are about 5,000, 6,000 feet. All that area was covered under ice. Yes.
So from 140 million years ago
Yes.
to 15, 20,000 years ago, it was this continued glaciation, and just it denied the landscape any chance to evolve. Is that what is going on?
Not necessarily, but frankly, we don't know. Because it's all just missing now. There's nothing, there's no record of what was going on in
You
there.
can't prove it. You have,
Right.
You suspect that you can't prove it.
Yes. But probably not ice. The ice has only been in the last 1.5 million years.
Really?
Yes. Several ice ages,
Got that big
not,
space.
and it wasn't all cold. For instance, about 125,000 years was an interglacial period. It was as warm as this now. And then it has another ice age. This is a picture that I took of Mount Katahdin about
15,000 years ago.
Yeah, nice time machine there.
This is what it would have looked like. Maybe the top was out, maybe not. This is what it looks like now. And so one of the things that this particular thing points out is that the shape and the surface of Maine now is determined by that last ice age. So you see these kind of funny valleys here with a very steep upper part and almost hollow in the middle. Those have a French name, came from the Alps, and they're called cirques, C-I-R-Q-U-E. And Katahdin has a couple of them, as you can see. And the knife edge, as you can see, it along there. So the other things that you see if you look carefully about it, in this rock, do you see the kind of curvy lines in the rock?
Yep.
Those are part of this being a metamorphic sedimentary rock, metamorphosed sedimentary rock. This is what's called a glaciated surface. So it was deposited in a completely different environment, 140, 100 and probably 400 million years ago, it's really hard, and still the ice, the mile thick ice, was scraping away whatever's on top of it and smoothed it out. You can find rocks like this, and if you look carefully, you can see some lines coming down like that, and there's some over there as well. Those are glacial striae, so you can imagine a boulder kind of grinding that line as it moved across the rock surface. And this is another kind of deposit that you see. This is known as glacial till. I don't know where that word came from, but it's T-I-double-L, simple enough. And it's what I guess most people have in their backyards. It's a mixture of obviously boulders and fine material and sand and pebbles. Okay. So where do you think they came from?
Left behind.
Yes, left behind by the glacier. And where did the glacier pick them up? Further north. Not necessarily Canada.
Also from the way.
Yeah. From away. Maybe just from Farmington.